A giant star collapses, crushing itself into a point so small and heavy that the laws of nature simply break. You click because you want to know if black holes truly destroy everything they touch and what the final moments inside that darkness actually feel like. NASA data confirms these objects aren't just cosmic vacuum cleaners, they are traps where time itself stops working. While we see them as distant shadows, the truth is a terrifying distortion of reality. Where are you watching from today? Tell me below. Let's cross the event horizon. To understand how a black hole destroys, we have to look at its point of no return. NASA defines this as the event horizon. Think of it like the edge of a massive waterfall. Far away, you can swim against the current, but once you slip over the lip, no amount of effort can save you. For a black hole, that current is gravity pulling at the speed of light. Because nothing can travel faster than light, nothing, not even a beam of laser, can escape once it crosses that invisible line. The first major mechanism of destruction is spaghettification. This sounds like a joke, but it is the brutal scientific reality. NASA explains that because gravity gets stronger the closer you get to the center, the pull on your feet would be millions of times stronger than the pull on your head. As you fall in, your body would be stretched out into a long, thin string of atoms. Imagine a piece of Play-Doh being pulled from both ends until it snaps. This happens before you even reach the center. The second best point to establish here is the accretion disk. This is the glowing ring of gas and dust spinning around the black hole. NASA's Chandra X-ray Observatory has shown that this material is moving at nearly the speed of light. The friction is so intense that the gas heats up to millions of degrees, blasting out X-rays that can sanitize entire star systems. You aren't just being pulled in, you are being incinerated in a cosmic blender before you even touch the surface. NASA's NICER mission has recently tracked these heartbeats of light, showing how black holes consume stars. They don't just swallow them whole, they shred them. This is called a tidal disruption event. A star that gets too close is pulled apart into a stream of gas that wraps around the black hole like a ribbon. That realization would be enough to classify black holes as the ultimate monsters. But what happened next made the physical destruction look minor. We realized that black holes don't just destroy matter, they destroy the very idea of now. That decision to look closer at the light revealed a terrifying secret about time. As we move past the event horizon, the tension moves from physical stretching to time distortion. Wait, before we dive into the center of the void, if you're finding this cosmic breakdown fascinating, hit subscribe. We're decoding the cold reality of space every week. According to Einstein's theory of general relativity, which NASA has proven using atomic clocks on satellites, gravity warps time. Near a black hole, gravity is so strong that time slows down to a crawl. If you were falling into a black hole and someone watched you from a telescope on Earth, they would never actually see you fall in. They would see you get slower and slower, turning redder and redder, until you seem to freeze forever at the edge of the event horizon. This is called gravitational redshift. To the outside world, you are a ghost frozen in time. But to you, falling in, time feels perfectly normal. You would look back at the universe and see billions of years of history pass by in a few seconds, like a movie played at 10,000x speed. While you are watching the universe end, the singularity is waiting. This is the third mechanism, the center of the black hole. NASA describes this as a point of infinite density. All the mass of a star, squeezed into a space smaller than an atom. Here, the math of the universe fails. We don't have a theory of everything to explain what happens when gravity is this strong. The real drama lies not in the darkness, but in the information paradox. If you throw a book into a fire, you can technically reconstruct the pages if you have the ash and the smoke. But for decades, scientists thought black holes destroyed the information of the atoms they ate. NASA's study of Hawking radiation, a faint glow that black holes emit, suggests they might slowly evaporate over trillions of years. This leads to an escalating severity. If the black hole disappears, does the information come back, or is it gone forever? While we struggle with the math, the black hole at the center of our own galaxy is already preparing its next meal. This is the peak of the truth, the supermassive engines. This is the highest informational value I can give you. Black holes don't just destroy, they build the universe. NASA's James Webb Space Telescope and the Event Horizon Telescope have shown us Sagittarius A*, the black hole at the heart of the Milky Way. It is 4 million times more massive than our Sun. The climax occurs when you realize that every major galaxy has a supermassive black hole at its center. These aren't just traps, they are the anchors. The highest informational value lies in feedback loops. When a black hole eats too much, it burps. It shoots out massive jets of plasma that extend for thousands of light years. These jets can stop new stars from forming, or they can trigger the birth of a million suns by compressing gas clouds. NASA has captured these cosmic blowtorches in distant galaxies, proving that black holes act like a thermostat for the entire universe. The reality of 2026 is that gravity and light are 80% of the mystery. The moment you see the shadow of a black hole, like the famous M87* image, you are looking at the edge of the known universe. You're seeing where physics says no. It proves we have created a flow that has value because it's a dark version of a hidden truth. But there's a silent trap waiting at the end of this success. Everything I just showed you about the singularity is useless unless you understand the one thing I didn't mention at the start. Most people think black holes stay black forever. That decision to ignore the end would have been enough to miss the point. But what happened next made everything before it looked minor. We have traveled from the spaghettification at the event horizon to the time warp of the singularity and the anchor, black holes at the center of galaxies. The resolution here is understanding that black holes are the ultimate recycled materials. You now have the roadmap to the void. You know why the 109:1 ratio of stars to black holes matters. You know why the Hawking radiation is the key to the future. You know why the supermassive anchors hold our home together. The expert status only comes after the very active work of realizing that destruction and creation are the same thing in space. Bring your expectations down to Earth. Focus on the fact that black holes are the reason galaxies exist, so our species can actually take flight to the stars. But there is one thing I did not mention at the start of this video regarding intermediate mass black holes. In 2026, NASA confirmed the existence of middleweight black holes that were missing for years. They are the missing link that shows us how baby black holes grow into the monsters at the center of galaxies. They are the evidence of a growth cycle that spans the history of time. Navigating the transition from amazed spectator to cosmic thinker is the hardest part of the journey. It requires you to stop being afraid of the darkness and start being awed by the power. If you can master this perspective, you won't just see a hole, you'll see the engine of the cosmos. You have the data and the framework. Now you just need the discipline to keep looking up as we reveal the next layer of the dark. Black holes are not just a death sentence, they are the signature of the universe's power. The center of a black hole is a mystery, but the journey to get there is a biological nightmare. Watch this video next. It shows you the exact physical breakdown that happens to the human body during the 9-month trip to Mars. Click it now and I'll see you there.